Good morning, everyone, and thank you very much for joining us for today's webinar, TEUI-4, the Next Generation Canadian Building Energy, Carbon, and Economics Modeling Framework. My name is Shalika Sivathasan, and I am the Administrative Assistant in the Continuing Education Department at the OAA. We will begin today's webinar by acknowledging the land on which we are meeting and calling in from. For millennia, the place we call Ontario has been inhabited by Indigenous peoples and nations who have been stewards of the land and who are deeply connected to its rich cultural and natural landscape. We would like to invite you in a moment of reflection to acknowledge our shared responsibility to address past and present injustices and provide space for Indigenous knowledge and worldviews to shape the architectural landscape of Turtle Island. Before we begin, I would like to share some important information to ensure an effective and professional webinar experience. Please be informed that this session is being recorded for quality and educational purposes. For accessibility, we provide automated closed captioning service available in multiple languages to accommodate the needs of our diverse audience. In order to maintain a stable internet connection, we have muted all participant microphones and disabled video feeds. Kindly note that the chat function has also been deactivated. However, we do highly encourage engagement through our Q&A window, which you will find at the bottom of your screen. Feel free to submit any questions you may have for our speaker there. Questions will be addressed during the designated question and answer period at the end of the presentation. For those seeking continuing education learning hours, please note that attendance is crucial. A minimum of 80% attendance is required for these hours to be accredited to your OAA transcript. Please allow just a few weeks for the processing and reporting of these hours. And lastly, please note that the presenter does not provide insurance, legal, or practice advice, and the OAA does not bear responsibility for errors or omissions in discussions during the webinar. Now, I'm excited to introduce our speaker for today's session, Andy Thompson. Andy has 28 years experience in ecological building design, construction, and research. He founded Thompson Architecture, Inc., a research-based firm offering advanced ecological prefab and BIM plus BEM design services to design teams on complex, high-performance projects in Canada, the US, and the EU. Andy is a past counselor and VP with the OAA and an active member of the OAA's Climate Action Advisory. He co-founded the Canadian nonprofit OpenBuilding, dedicated to advancing BIM and BEM solutions for architects and engineers. And he is the project lead for OpenBuilding's Objective suite of software tools for early-stage energy, cost, and carbon modeling. So welcome, Andy. In today's webinar, Andy is going to be doing a demonstration of the Objective software tools that I just mentioned. And so we're going to copy two links into the chat where you can access these tools and resources so that you can follow along during Andy's presentation. You should also have received these links along with your access link for today's webinar. And with that, I will pass it over to Andy.
Great, thanks for the intro, Shalika, and you've got a great voice for radio. Awesome intro, thanks. So I'm going to be speaking to you about TEUI-4. As you may or may not know, there's a history to the OA's TEUI-4. Whoops, I gotta make sure my screens are there. It is now called Objective for a particular reason, and I'll get into that. The OAA TEUI 1, 2, and 3 used to be projects under the Sustainable Built Environment Committee, which is now an advisory, an ad hoc advisory. And for lots of reasons, we've moved it out into a nonprofit to continue to develop in between academia, private, and public bodies so that we can kind of pursue our independent research on making the tool as good as we can based on real buildings in the field. And I need to thank, this isn't just a project of mine or the OAA's. There's a lot of amazing people that have contributed to it. The original idea was one of Ted Kesik's, where he had a standard in mind that he wanted to call a really simple building. He'll be speaking to that tonight. We're having a launch event at the Drake Hotel. So if you didn't know about that, we've still got 20 tickets available for that. We just expanded capacity, and that is launching the Objective software, and it comes with a light dinner and drinks provided. If you're an OAA member, and if you're here, you're probably an OAA member. Mark Paludis is our CTO. He's been behind a lot of the technical stuff. That's the second to the left. I'll just go through in order. John Peterson from MJMA, Sheena Sharp, Pam DeMello Engineering from EME Hubbard, and Barry and Vaughn, Joanne McCallum, who's one of our new directors, Jeannie Ng from MJMA, Evelyn Bouchard, who, if there's any of you that are using Passive House, I've got a special little segment where she's got a pre-recorded piece on people that want to put together PHPP and Objective and figure out how they work together. And then Emma from Envisage in Hamilton, and Grant Walken in Winnipeg, and Daniel Gignac, who presented with us at Niagara Falls Conference, Chris Magwood, who's been providing collaboration on the embodied carbon components of the tool, and then of course Lara, who's also been using this and is our new OAA president. And Graphisoft and Sega have been corporate sponsors for the tool as well. So all of that has helped make the tool better through peer review and continuous advancement and development. So I guess Shalika is going to pull up the poll questions. We've got 3 of them, but I'll just kind of go over why we want to ask these, because I'll tailor the content to speak to the questions based on how you're going to answer these. So client priorities is really like you just sort, it's going to be a ranked poll. What are the most important things from your client's point of view? So if you can kind of put those together, we've listed 4 A, B, C, D, E, five categories. Just rank them in order. Oh, I see 4 there. There's a weird one. Okay, anyways. Yeah, there should be 5. I think the panel, you got to scroll the little horizontal thing and the 5th one shows up. So design, sustainability, operational costs, or capital cost, or lowest consultant fees, and you can put those in order. And then the next one is current capability. And this is where we're just asking, are you already doing some form of life cycle analysis, energy or carbon modeling in-house already? Or are you using external consultants? And the third piece is if you're using PHPP, if I see more than 20 people responding, yes, we're using PHPP, I will show the PHPP video segment from Evelyn. Otherwise, we'll just cover the basics of the tool. And then the next one is main barrier to adoption of these kinds of tools like LCA and energy modeling. Is it client expectations, or that we can't charge for it because it's not typically part of our contracts? Or do you foresee that there's liability or targeting a number that might be too low and then you're going to trouble for it if your building doesn't actually hit that number? Or is it something else like staff time, skills, or training required to learn this stuff? And there's just not enough fee to have staff time go off and do all these kinds of things. So we're in a webinar, we're doing this right now. So I'd be curious to see what your answers are, and then we'll kind of advance to the next piece. So while you're filling out the poll, I'm just going to give you the QR code for the Excel version. Now, the Excel version is where the tool kind of emerged or developed from EY2, our second calculator. It developed into a spreadsheet because there just became more and more inputs to deal with. The Excel version of the tool is going to be sunset next year, so in 2027, because it's just too difficult to maintain. Once obviously an Excel file gets out in the wild, you can't update it, right? Everybody's got to download the newest version of it. So we've moved everything over to a web version. The Excel tool has its place if you want to kind of customize it. You can add tabs to it. There's all kinds of things or ways you can extend it for big building studies. If you're, for example, one firm is doing a study of all kinds of buildings in a municipality. They're looking at 50 different city-owned buildings and running them through the analysis of objectives. So that's one of the uses. So it is a $100 by donation through OpenBuilding. The website is there and the QR code will take you to that. And then, whoops, up to my keynote. There. That's kind of what the Excel version of the tool looks like. So you see the big numbers in the top. Those are the key metrics we want to keep our eyeballs on all the way through the use of the tool. And here's the QR code for the new web-based version. So there's no donation required. It's free software. It's available on the web. The website is objective.openbuilding.ca. You can save the QR code, but the link that Shalika shared at the outset, or it's in the chat, it has all these resources links on there. So what I'd encourage you to do is click the link open so you're looking at the Objective website, and then you can kind of follow along as I'm showing the examples of how the tool works as we go through it. And it will kind of look like this. So once you get that launched up on your screen, that's sort of what the interface looks like. You may not see the graphic. We'll get to that now to navigate the tool through all the sections, but that's part of what we'll cover. So how did the EUI tool come about? We Now, Shalika, I don't know if you can hear me or if you can answer, or when will I see host and panelists can't vote? Okay. So do we have the results of the poll yet that I can see? Let's see. Q&A. Okay, we'll come back to that later. Um, the reason the EY tool was developed, there's a few of them, but for a lot of practitioners that don't do big buildings like Part 3 or something else, they might do a house and then they want to submit for an OAA award, for example. One of the requirements of submitting for OAA Design Excellence Awards is you have to submit your EY for the building. And if you didn't do an energy model, how do you know how to do that? So this is one of the requirements is to make it easier for practitioners to actually submit that number. We developed a tool because when you say, well, we need to hit an EY target and you're over there on the right side of the canyon and we're over here on the left, how do you bridge that gap if there's no tool for architects? It's only tools for engineers and they're all advanced and they have 500 inputs and they're a complex interface and everything else. So EY 1 was developed to answer this question of, well, what are we doing? We're basically just taking the total energy from the building and dividing it by the area, and that gives you the EUI. So TEUI 1 was the first generation of the tool, and that was back in 2020. So 5 years ago, it seems like an eternity. Um, and the basic formula is you have all your energy from utility bills, and on the web page that we shared, if you scroll midway down, you'll see the YouTube videos that cover the past sessions that dealt with TEUI 1 and 2 and 3. And then you tally up your, if you don't have an energy model, you can gather the utility bills, total them up for a year of occupancy, as long as they're 12 consecutive months, it doesn't matter where you start and finish. And then you divide that by the conditioned area of the building. In this case, it's 50,000 kilowatt hours a year divided by 528 gives you an EUI of 94.7. So that's the total that we're targeting. And you can think about that like a miles per gallon number. So when you know that, this is kind of how your building is performing as an intensity metric. So then members of the SBAC asked us this question was, well, that's fine. We can take the total of EY, but when something like Toronto Green Standard is asking for TEDI or Passive House, TEDI is a really focal metric in that standard. How do we determine what TEDI is? Well, TEDI means different things to different people, it turns out, and there's lots of different ways to calculate it. So we've been in debate on this for about 4 years, and parsing TEDI, which is thermal energy demand intensity. Basically, what that means is how much thermal energy do you have to provide from supplied or purchased energy to put into the building, which is then subsequently lost through windows and roof and walls and things like that. So, yeah, I think, right. Sorry, I'm just trying to read the poll. So we developed the first version of providing those answers. It looked sort of like a nutrition facts label. It was called TEY2. And I wouldn't say it was the most successful implementation because we're kind of groping in the dark as we're trying to figure out how do you actually separate TEDI from TUI. So let's say that was just an experimental, it was going in the right direction, but the TEY tool really didn't answer the questions for people. It was a little more complicated to use. Arguably, the version that we're on now, 4, is a little more complicated, but we're still trying to keep it simple, and I'll show you why and how. TUI 3 then really started to suss out how do you separate all these inputs and outputs so that you end up with a balanced energy uh, building energy model. So we'll just take a quick look at the actual spreadsheet version of UI. This is TUI 3, 3.046. That's the last version that was published in December 17th last year. And if you look at the tabs, I'm just going to move my Zoom controls here, the energy balance is kind of key. So the supplied energy going into the building ends up being lost energy. So if you're putting so many kilowatt hours into the building through a heating system, that heat finds its way out either through unrecovered ventilation or gains that can't be utilized or air leakage through the envelope or uh, energy loss through thermal bridges or the floor slab or any of these things. And in a balanced energy modeling system like PHPP, you will see there's the supplied energy and the lost energy. And then you can look at this in a different way. This is sort of more like how Passive House is looking at it. And then we also did a version where you're looking at the energy supplied or energy that ends up in a building. Usually you don't want it in the summertime, but this is a cooling season energy balance. So it's sort of doing the reverse. And it says, well, if you're gaining all kinds of thermal energy from people in the building, you have to remove that either through a combination of ventilation, nighttime ventilation, air conditioning, dehumidification, or whatever. So that energy removed, we now have a balanced energy system that looks at the heating season and the cooling season through that. So back to the slides. Now, the way that the EY4 tool does it is TEDI is on the building supply side. So this blue bar in the center, this is a Sankey diagram, a really handy diagram for showing how a building works. But you have all the energy inputs on the left, they travel through the building, and then you have all the energy lost on the right. And the TEDI is on this side. It's the thermal energy demand. It's the demand on the heating system to the building so that these things all balance out, right? You're providing enough thermal energy with these other inputs, things like occupant gains, lights emit a bit of heat, windows can contribute a little bit of solar gain, and they flow into the building and then they flow out. And then on the other side, the losses side, we have renamed this TELI. It's very similar to TEDI, but they're not the same size, right? You can see the bar here is bigger than the bar here. TEDI is the thermal energy required from the heating system, and this is what we're losing through the combination of windows and thermal bridges, but not ventilation. And this is really the direction of Dr. Ted Kessick, who is one of our he's our chief technical advisor for the system. And then unusable gains you can see going out through here. So TELI stands for total envelope loss intensity. That's a key metric in objective, and I'll explain how that works in the tool. So if you look at the web page that we provided, which is this one here, Objective 4, and if you can't find it, if you just go to openbuilding.ca and you want to find out, oh, that resource, it had all the list of stuff that I need to access for later, you can just type in OAA in the search, and it will give you a bunch of stuff. And it's this one, Objective 4. That's the easiest way to get to the page from all the menus that are on here. So this is our session today, resources from our 2026 webinar, tools for lifecycle analysis. And the first part, we're already 17 minutes into it, so I've only got 12 minutes to cover this. But these are the questions, the kind of things that we want to try and answer in this first half hour before I dive into the tool. So I just wanted to find out if there's a way that I can see what the answers are to the poll. Shalika, is there oh, there we go. Got it. Okay. So good. Polls and quizzes. The design, it's hard for me to tell. The value most, yes, capital cost. So this is what I expected to see. Most people answered that capital cost is the most important thing to a building owner or a client. It's unfortunate, but true. And so instead of sustainability as the principal most important thing, and I'm glad to see there's some, because often we do sessions and there's none. So some people are answering. Sustainability is number two. It's one of the least important things people consider, and design is nearly at the bottom of the list. So how ironic, we're all designers and we know that most of our clients value design the least. Capital cost is more important in the public eye than climate or low CO2. So the way we tooled the objective application is to focus really on the capital cost and the capital cost improvements, because what we've proven time and again with all the buildings that are in our case studies are that the least carbon, the highest performance building can be capital cost neutral, but it's saving you a lot of money in operating costs every year. So the thing that's surprising is there's a substantial bias that these solutions will cost more in terms of capital cost, and they do not. Most often, the low carbon materials are less expensive than the high carbon materials, and that's a function of just all of the energy intensity that goes into making steel compared to making timber, as an example. And low consultant fees. Unfortunately, there's a lot of people that also think that that's the most important thing. So one of the aspects of the design of the tool was to make it easy to use. And if it's easy to use, then it's easy to adopt, and it's quick to do the modeling. So the way it works is if you open up objective.openbuilding.ca, that's the second link provided in the chat, you will see this app. And what we're loading is there's a building that's already kind of preloaded. It's our sample building. It happens to be an event center that's near Innisfil, Ontario. It's one of the buildings that we did. But the benefit of this one is we've got really good data on it. We've got all the utility bills, the water bills, the air conditioning loads, uh, everything from the building automation systems. So we know that this is what the building's actually doing. Um, if you look at the three sets, there's six numbers up here, well, nine numbers. The first line is lifetime carbon. I'll explain what that is in the second half. Annual carbon, that's your emissions in a given year from the building itself. Um, and then EUI is the third line here. 198.1, that is what the building code would expect this building would perform at. This is what our modeling tool here is going to be kind of setting as a target, saying, well, this is, given everything we know, this is probably the EUI you will see. I'm going to say, be very careful about using the word predict or estimate. We'll get into that. And then the actual is what the building's actually doing in real life based on the utility bills. And the section that deals with that, so there's a bunch of sections. You can kind of scroll them down, up and down here. There's 20 sections. And the idea is to have everything in one sheet. So you're not browsing multiple tabs of a spreadsheet. You're not having to go through a deep layer in layer menus for things. And anything I change with these little simple sliders updates the model on the fly. So every time I change something like service life or any value, I'm always seeing a live update of what the model's doing in the background. So the calculations are instantaneous. I don't have to look through a 30-page report at page 19 to figure out what the EUI is. It's all in black and white at the top of the app. Um, so making it easy is important, and that plays into our fees. And most people don't use PHPP, so we'll skip that. There's only 1 out of 42 that do that. Some of you do in-house energy modeling. That's great. And most of you are using external consultants. So this frames how I'm going to speak to the rest of this. What is the main barrier? Client expectations. So we'll get into that. Liability and target risk is in there. Staff time training and skills is another piece. So what I will say on the training front is that we've taught this to students at McGill and other universities, and they've picked it up in a 4-hour session to run studio projects on. So if they can learn it in 4 hours, we can all learn it in 4 hours. We have a dedicated training session where we can come and do stuff in office, but we'll be offering throughout the year sessions on how to actually really dig in and gather all the information and do this stuff. In the 90 minutes we have here, I can only really give you a cursory overview about how everything works, but we'll dig into it now. So I'll just start going over the tool. Actually, changed my mind. We're gonna speak to this issue here first. It's item number 10, and it's avoiding language like predicted, because a lot of you are not using these kinds of tools in your practice already. And so if you were to talk to someone like John Hackett at Prodemnity, they would not want us to be using something and declaring that we have confidence or that we're any kind of energy expert in it. The key to this whole thing from a liability and a risk management point of view is that you don't want to make any claim you can't support. And so we'd always recommend learning the tool in the office, spend a year and benchmark your performance. So the way to do that is speak to your clients, follow up after a year of their occupancy and say, we would kindly request that you provide us with your energy bills. We'd like to kind of calibrate how our buildings are doing. This is quality, standard quality assurance. Circle back, get the information from them, put it into the tool, add in the energy bills, and find out what the building targets and what the utility bills are. And once you've got 10 or 12 projects in your firm's own portfolio, and you see how the targeting works and you get comfortable with the tool, then I think that's a good time to start using it in client-facing communication. So most of us that have started with this kind of keep it close to our chest. We work on these, we figure out what our buildings are doing. We don't really tell the clients about this. And then when we gather more confidence and experience, then we can start to stick our neck out of our turtle shell and say what we're doing here. Now, to give you an Olympic, well, I'll talk about the Olympic analogy later, but this is a tool, just like a hammer is a tool. And there's a lot of ways you can hurt yourself with a hammer. So using words like estimate or predict are going to get you in trouble. So are warrant, assure, guarantee, or using any of those kind of things that are always red flags in an RFP. It's the same kind of thing with energy modeling. There's a lot of reasons, and I'll explain some of them. So let me just jump to those slides in the deck because that's an important component of what all this is. So here's an example. So we've got one image, and what we say is that the energy model estimating is for suckers and optimization is for professionals. So where we want to be is kind of in the middle here. where we're setting a target and we're kind of circling in on what the building's going to do with limited information and knowing that there's lots of unpredictability in things like user behavior and weather and assumptions about the expertise of the modeler and a bunch of stuff. So this is really saying the real numbers are the only thing that are going to tell you what a building is doing. Otherwise, it's like predicting the stock market. So you can see in the ideal case on the left, that's a building that I built. It was my own house in Quebec. And we had an EUI estimated um, at 48.78. Well, that's what the building's actually doing. We built the exact same building for a client in Ontario near Collingwood, and the numbers from their utility bills came in at 103. So what's the difference between 48 and 103? They weren't, in fact, what you would think. So you can see, same building. That's my house on the left. That's my client's house on the right in Collingwood. Um, I'll just go back to that slide. Down in the bottom, there's a disclaimer from ASHRAE 140, and it says specifically, actual experience will differ from calculations of energy modeling tools due to variations such as occupancy, building operation, maintenance, commissioning of systems, does everything work properly, weather, like who would have predicted the last 2 weeks, 3 weeks would be this wicked cold snap, right? That would affect your results and also your carbon emissions if you're making that as a forward-facing statement saying, this building is going to do X. Water use is a big one. Energy use not covered by the standard. Changes in energy rates between design of the building and occupancy. ISO is just cranking up rates of electricity and probably gas also in Ontario. So those are things that if you put them in a paper and say this is what the bills are going to be, you're going to hang yourself at that rope. So here's another example. This is also from my house in Quebec. And you can see it's the same house, same occupants, charging an electric car, all electric building, everything else. If we look at the top left here, 2016, 2017, and 2019, we've got 20 to 30% variability just in the weather year. So when you do energy modeling with most tools, it uses something called a TMY, which is a typical meteorological year, and it averages a mashup of all the weather. But you can get outliers on either end, right? It could be a really cold year, it could be a really warm year. So you need to know that just the weather can throw the results by 20 to 30%. So that's that piece just about disclaimers. And in this page, when you scroll down, we've got our end user license agreement for the tool that's down in the bottom here. And we highlight this piece from the ASHRAE standard. Actual experience will differ from these calculations. So you really just need to be careful that what we're doing is we're trying to figure out what the building is going to do, but the only thing that's going to give you the truth is the utility bills. So that's what makes this tool objective because we circle back and we put the energy bills into the tool. And then further down here, you'll see we've got a bunch of case studies. So the case studies document, it's a PDF. It's got 13 buildings in here, and it shows what the building code thought this building would be, what our design was is the middle number, and what the actual is right here. So I'm going to jump right into the use of the actual tool so I can kind of show you these things. So this building, the way it loads up, might not look anything like your building, but that's okay. You can edit and you can alter. So when you click an import or export, we can import data from the spreadsheets, right? So I can import and I can point to a spreadsheet from, let's say, case study buildings. We'll pick Evelyn's house in Quebec, Meadow House, and open. This is actually loading up all the data from the Excel. So the cool thing about this tool is we can, for backwards compatibility, we can still read files from the Excel. But also, we've loaded up some of the sample buildings from the case studies in this little load building thing here. So you can go to a passive house residence, Part 9 in Hemmingford, Quebec, or you can look at this Part 9 duplex in Port Credit, Ontario. So let me just load that up. It gives me a little warning. That's the data from that. That's a net zero project, which is why the numbers are so low. It's offsetting a whole bunch of stuff with solar. And then we can look at this athletic center in St. Catharines, load that up. That's also a net zero building, right? So numbers are really low. Or I can try a MERB. So I can go load sample building. Let's pick this one, a mid-rise in Woodstock, Ontario. Click on that. It's Part 3. Okay. There you've got our sample building. So you can start from here if your building is like one of these buildings, and then you can just edit the values from there. So I'll just get into explaining the interface a little bit. So you've got this scrolly thing, and the key values always stay at the top. But then you've also got this little arrow icon in the upper right of this key values header. So that's section 1. If you click on that little arrow, it turns it into a tabbed interface, which I think is just a nicer way to navigate the tool. It kind of brings you through, and I've got it pumped up fairly large. It's like 110%. But with your browser controls, you can shrink or enlarge just like you could text if you're looking at any web page. So you've got all the various sections separated into this horizontal tab. And then you've got a few graphic sections, and they start just folded up like this. But to give you that graphic of what the building is actually doing, there's the Sankey diagram. So all these inputs, the things that are in blue, those are the things that you're going to input. The things that are in black, all the values in black are calculated. So the very first thing we do is we set up the building with the occupancy type. Is it A, assembly occupancy? These are all the same kind of things you would have to put in for your OBC matrix. So same, you just follow that logic. Is it D, business and personal services, mercantile, industrial, or so on? If we say it's A assembly, then we can set what building code we're going to use. So it would probably be some form of SB10. That's an old one from 2010, but here's a Zone 6 SB10 5.5 to 6. And then I can say, I don't have utility bills yet. It's targeted use. So this means I'm going to put in a design. That means the actual section goes to 0. So if you don't have utility bills, don't put that in here. You're just going to use the targeted use method, not the utility bills method. And that will just 0 out. And then you can go back to your client a year later or 12 months post occupancy, get the utility bills, and then put those in. And I'll show you where those go. So there's two things here. One of the pieces is we give some contract advice in the references. Let me just find where that is. I think it's up top here. Oh yeah, sample language, it's in red. That's this one right here. So down in the references section, so we've got headers on the left here. This is references. This is on the resources page. There's this little piece that we put into all of our standard OAA 800 and 600 contracts. And this gives us the expectation that we're going to follow up after the client has occupied the building. Owners shall provide energy bill data 12 months post occupancy to the architect for the purpose of determining the TEUI of the project for awards, training, and quality assurance, just like the disclaimer Shalika read at the outset of this session. So if you put that in your general terms as an additional thing, nobody's ever objected to that. They could and strike it out, but almost everybody is, every client that we've seen is encouraged that the architect is invested in circling back and getting this information. So once you've gone through that process and you start to build up data for your portfolio, where you put that in is in the target section. So it's the third tab. So I'll just expand the sections again. Here's our building information tab. There's our climate information, so our weather data. And then we've got our targeting section. So this is sort of a total section. So if I have 120,000 kilowatt hours per year from all the electricity bills, I can hit enter. And when I go to report it, whoops, I'm going to put in utility bills, then I can see I've got a different EUI there now, 73.2. That appeared just on the basis of these two numbers, the area, the conditioned area of the building. So let's put in 2,000, not 20,000, 2,000 there. And then I put in 100,000. Right? That's the actual, this is related to the actual energy from utility bills. That's where you put these in. So if I use any natural gas, I would put that in like 5,000 meters cubed per year for the total year, 12 consecutive months for the whole building. And then it gives me the EUI number. So this is just like what the old EUI calculator was doing when it's only dividing energy divided by area. Then there's all this other stuff that we've added as a kind of layer over top of that. So I'm just going to go to the reset and hit factory reset, redo all this stuff, and I'll show you the kind of more of the basics of the interface. Okay, I'm gonna have to do a rebuild. Oh, it's the slow. There we go. So there's our default interface. We can rebuild or we can do factory reset to kind of bring us back to the baseline. So occupancy is set here. What building code we're doing is set here, and I can hit set values, and that establishes the building code reference standard. So there's a whole reference model system in here. That's these three numbers on the left, right? The 1, 2, and 3. And um, the way to toggle between the reference model and the target model is with this little switch. So right now, this little switch in the upper right turns everything red or black. So when I click it into the red, now I'm editing the target model. This is my building code baseline minimum. This is the worst building you can legally build, right? And it's what it does is it sets up all the standards in here to match what the building code sets. So for the building code that I selected, which is SB10 5.5 to 6 zone 6, right, from OBC, it shows me in the section 11 the transmission losses. So this is the U values, the R values of my roof, wall, floor, and so on. And you'll see the reference values in this column here on the right are all 100%. So that is the baseline, the value that I must do better than, right? So it says here that my doors have to be a minimum of U value 1.99. My windows have to be, or sorry, a maximum U value of 1.42. My RSI for my roof is has to be at minimum 5.3, and so on. And then when I toggle the switch, you'll see even when I'm scrolling up and down, this switch is always available to toggle back and forth. So when I go into section 11, I can click this toggle again, and I can see, well, my building actually is, we're putting 9.35 in the roof for the RSI value. That means I'm 176% better than code. So when you see a check mark here, what that means is I'm passing the requirement of SB10 because my value is 176% greater than the code minimum. So that's how the reference model and the target model work together and show you the kind of values and where you're at in terms of the energy model. So when I look at the top here, I've got a few different buttons, right? We are import export. We can save this out as a CSV. So once I've made some changes, I can go export, and then I can save it to my desktop, and just it auto names the file based on the information that you put in here. So this is Three Feathers Terrace by Thompson Architecture. There's my license number. When I go export data, that's the file name it gives it. It says dual state. That's the type of energy model it is. Three Feathers Terrace is the file name. And then I can save that down. That means, so you can see, I haven't made a lot of changes here to the area. Yeah, let's just change this to 2000. And I will change this location to Attawapiskat, right? So another A, but a very cold location. So that's going to push up the energy use a little bit. And I'm going to go export now and save. And then if I rebuild everything again and reset the app to the way it loaded up originally, right? Where I had Alexandria as the, sorry, I bet it's slow because we've got a lot of people, probably 180 people on this webinar that are looking at it at the same time. So this is a good test for the server capacity if we're all looking at it at the same time. So if I wanted to import that file, then I can go import data and I can browse to my desktop and I can look to sort by date, dual state, Three Feathers Terrace. And instead of the default, I should see that location that I had in Attawapiskat load up, right? That's what it does. So import and export is by CSV. And that file, if I wanted to look at what it does, I can just sort to desktop. Click on the file. I can open this in any spreadsheet, and I can look at what those numbers are. So at the top, the top row, you'll see the building occupancy, and then you'll see the metadata for the standard, the utility bills. The second row is your target model, and the third row is your reference model. So when you scroll through that, you'll see all the values that were output from this file. So if I change the location to Attawapiskat, but I didn't change the location in the reference model, they're showing two different values. So if I switch back here and I change the location, so the location here needs to be Attawapiskat also, then my reference model will also change to update to that location, and then I can toggle back. So the reference and the target model allow you to do completely different buildings. It could be a Home Depot in Chilliwack and a Home Depot in Toronto, or you could have two buildings in Toronto that are totally different buildings, but they're both using the same location. So the reference model gives you a wide degree of latitude between the from the target model. It's not using all the same values necessarily, unless you copy them over. So help is contextual. So if I've got a help button on the top left here, and I can switch it on. So if I switch it on and I mouse over any one of these inputs, it will show me what I should be doing here. So if I mouse over the area, for example, net conditioned area, it tells me area is measured from the interior face of any wall, and it gives me a blog article that I can look at. Shows me open building conditioned area. So I can learn how to do that by visiting the blog on the Open Building website. So the help is contextual, but often it gets in the way because it's always got these pop-ups. So I'm going to just turn it off for now. Once I've set my location, like Attawapiskat, I can click on the more weather data, and then I get the full table of everything that is in the 2020 edition of the National Building Code. So there's 700 weather locations all across Canada that gives you all this data. So for your engineer, for snow load and lookups and all that kind of stuff, it's the same table, table C2 that's in the National Building Code for all these locations. Seasonal average temperature, wind speed, all this kind of stuff. So our app is using a few of these, not all of the data, but all of the data you can see that would be in that table C2 is available in the app with that more weather pop-up. So I'll just continue going through the interface. The reference model, this is just another way of getting to the reference. So I can go show reference or show target, and it's doing the same thing. You can see the little switch there is switching back and forth when I click on this thing. So that's getting me between the two models. The disclaimer, that's the stuff I already covered that says, be really careful about what kind of terminology you're using. We explicitly call this target modeling, not estimation, not prediction, for that reason. So it says targeted design. We're targeting things. And if we hit the bullseye, that's our actual. So this is actually less than the target, which is good. It means we're not in hot water. But again, until you get experience doing this, don't start using this in forward client-facing communications. Reset button is here. So undo changes. There's one level of undo, and then there's clear import data. That's if you imported the wrong file and you want to reset things just to that level without wiping out all your reference values and everything else. You can just go clear import data. And then OBC matrix, that's a future feature. It's not available yet, but if you fill out the OBC matrix, the idea is you've got your area, you've got your fire compartments, you've got your net building, your limiting distance, window calculation stuff. All of that is useful data that you could populate your objective model with. So one of the idea is in the future that if you fill out the OBC matrix, then it can kind of auto-complete the objective model here. So reference model, this is refresh, and then this will collapse all the sections, right? This little plus minus button. So this opens them all up or collapses. And the reason I would want to do that is if I'm printing a report, I might not want to see the indoor air quality section. So if I just click on that section, it folds it up. And then if I go print, which is just Command P on your browser, that section is folded up. So you won't see the data for any section that's folded up. It just skips it. But I can see these graphic sections are not showing. So in the print view, you might want to see those. So we can show and hide whatever we want by doing that. And then the last page is a disclaimer, right? So it just says where the software came from, how the models work, what the user license is, and so on in a print view. So my recommendation, if you just make a mental note of this, is the best format to get all this to fit on a page is going to be if you select as an 11 by 17 or tabloid sheet in landscape format, and then you get everything. It doesn't print all the buttons, it just prints a kind of a stripped down version of the interface. So if you want to use this for reporting, it's a good way to do that. So this basically gives you a preview of what the report view would look like. And if I go and switch on the graphic sections like the Sankey diagram and like the optimized view, but I want to hide this thing called Wombat, and I want to hide the F280 tab, and then I want to print, now you'll see when I go to print, I get all those sections, plus I get my graphics coming through, right? So it shows me these sections that are kind of graphically rich with the disclaimer at the end. So that's how you print. There's no separate print command in here. It's just the browser's print, which actually works better than most things. So we'll go through the tabbed interface now, and I've got 15 minutes left to cover this material, so we'll go through it kind of sequentially. So climate has you pick your province, and it can be anywhere in Canada. Again, we have 700 locations mapped. And if I change this from Attawapiskat, you see I've got a heating degree day here of 7,100 hours, but I don't have any cooling. Let's put it back into Alexandria, which is Innisfil, and there's a cooling record in the tables for that. So if there's no cooling, you can actually type in a manual. I can say, well, there's 600 cooling degree days. I could put that in. It won't let me because it says there's 196. But if that information is not available for a location, like Attawapiskat, I could put in 12, and that will let me use a custom cooling degree day if the information is not available on the table. And then I've got current or future values. So let's see what the difference is. So if I go between present and future, right, I can see that the future requires less heating load because through climate change, we're getting warmer weather generally. And present is going to set me up with a more rigorous or a colder climate scenario. And the target is, this is coming from Environment and Climate Change Canada, the table, the data, it's built into the 2020 National Building Code and the National Energy Code for buildings. So I can see what those values are. And they are the spread between 1990 and 2020 as our present weather, and 2021 to 2050 is what our future weather scenario includes. So again, if you have utility bills, you put them in here, and this is what the tool is estimating that your uses are going to be based on all the data that you've fed it. And if there's different emissions factors based on the area that you're in, you can put those in as well. That's grid intensity or how dirty or clean the grid is. Those automatically populate based on province. So if I change the province to Nova Scotia, for example, let's put in Nova Scotia, Amherst by example as a default. I go to target, I can see my emissions factor for Nova Scotia is 600 grams of CO2 per kilowatt hours. Then I go back to Ontario and compare, what do we have here? And we look at target, I can see the emissions factor is 51. That's because we've got a relatively clean grid, not as clean as Quebec though. So if I go and I look at Quebec, and this is changing my embodied carbon emissions, right, for whatever city I go in. So if I go target here, it's only an emissions factor of 1 gram of CO2. So that affects this line here, the middle. So if I have an all-electric building, my carbon emissions are going to go down as a function of the grid intensity based on the location I've selected. So in Ontario, this is mapped out by ISO values, which means that for any city that I put in here, it's going to change the emissions factor based on what my reporting year is in the first section. So my reporting period, you can see if I drag it around here to 2041, 2028, because we're shutting down Darlington and doing a bunch of stuff and ramping up gas plants, and then the nuclear plants come back online. All that is built into the carbon emissions modeling for this slider. So if I look at the emissions for 2030, the estimated emissions from these numbers come from TAF and ISO. I go back into this target section. I can see for that year of reporting, it's predicted to be 106, right? Based on the reporting year that I put in my info section. So information is just general building information, the project name, conditioned area, my firm name, and my license number. The climate section deals with this stuff. Capacitance is complicated. I can explain that another time. And then we have our more weather data. That's just another way of getting to the same section. Then greenhouse gas emissions, I've got some different ways of doing this. I can pick a topology-based estimated carbon, embodied carbon number, and that just gives me like a ceiling. So I can say, well, I don't know, I'm not going to measure the carbon. I don't know what it's going to be, but this says 550 for concrete, and I don't really know, and I haven't measured it yet. I can put that in, and I'll see that affects my lifetime carbon. That's the way this calculation is done in Europe, and so we're kind of doing a similar thing. This building in particular is a Part 3 mass timber building, so it says 350. I can just put in 350, and that's pretty close to what this building actually modeled out at. Then I've got wind, water, and solar. So if I've got solar on-site or off-site renewables, I can put that in here. Water section, indoor air quality, internal gains. So this is your occupants. So we can talk about how to model that. But in this building, it's got a restricted occupancy to 126 people. So that's the number we put in, the same number we'd put into the OBC matrix. And then what's the occupant activity level? Normally, you'll put in normal. But if I had, for example, a long-term care facility, I would probably put in relaxed because seniors are generally less active and they have a slower metabolism. And then they're there in the building probably 24 hours a day. So this has a big impact on the internal gains and the cooling loads, but also use factors like plug loads and the intensity of lighting and all the rest of it. 12 is considered what you would normally do for a house. So if it's a residential occupancy, that's the number you should set. And this is kind of a global default for the whole year. And it just totals out to 4380 years of the 8760 in the year based on the usage. So if you were a Cineplex Odeon, you might put less than 8 hours, or I'd put zero, because there's not a lot of, there's only occupancy during a very limited period of time. So there's special considerations for different occupancies in terms of what number you'd put in there. Then the envelope and the transmission section, they kind of go together. This is radiant gains, so it's all your transparent things, windows, doors, things that are gaining and losing energy differently than opaque elements. So you put in the orientation of the window, the solar heat gain factor, if you know that, the winter shading and summer shading, these are kind of approximate. But what happens is if you alter these, you'll see the number in this row update. So if I've got a more permissive or a more restrictive, rather, solar heat gain coefficient, I will get less gains. But if I crank this up to 60, I'm going to get more energy coming through that window. So the heating season gain function increases to 229. So every line of the tool is updating totals. And then I can see here my net usable gains. That's another thing where if I have my help turned on, it will tell me what that is. I mouse over this and shows here's what you would put in for different types of buildings, right? So the help will guide you through what number to set for most of these inputs. Then I've got my volume section, which is how many stories. I'm sorry, the tool only goes up to 6 stories. So if you have a 50-story condo tower, you can just put in 6. It'll give you a kind of framework, but neutral pressure plane and air dynamics on a really tall building are very complicated to model, and we really didn't get into it with the tool here. So this is a reasonable limit for what the tool can do in terms of its targeting behavior. What you want to do here is, this is a one-zone model. You'll put the whole building in as one thermal zone, and that is the interior conditioned area. So if you have a basement and it's conditioned, you'll include that. If it's a slab on grade, there's a different way to describe that, but obviously you have no volume from a basement. If you have a parkade or a parking garage that's unconditioned, then you treat that as if it's a slab radiating to air. So you don't actually have, you don't include that volume of the parking garage because it's not conditioned. So that's the volume section. There's a mechanical section, and then TEDI and TEUI are totals. So the more fun stuff is this Sankey. So what I'm going to do here is load up a building. It's a big building. This community center in Milton. We'll go okay. So this, you can see it's got a much higher UI. I'm just going to calibrate this to decarbonize, then restore baseline, and I'll show you how this works. So this is the same building that we've got defined in an Excel spreadsheet, and it is this one over here. So you can see the values that are calculated in Excel are the same values that are calculated in the web app. 511 is the targeted EUI, and the actual use case, this is from real utility bills, is 508. So we're really close. And the idea with this whole approach is that because we're not trying to make an energy modeling tool that does what every other energy modeling tool does using the same methods, what we're trying to do is match the reality that we see in utility bills and then work backwards from that number. So the tool is designed to get as close to 508.5 as it can, instead of using a bunch of methods to end up with some number that may or may not even align with reality. And the Sankey diagram shows you what's going on with this building. So if you look at the energy supplied and the energy lost, what is the single largest energy loss on this building? And you can see it's kind of staring at you right here, unrecovered ventilation. So if I go to my mechanical section and I go, well, why is that? My HRV, ERV, or my mechanical ventilation with heat recovery efficiency is only 4.8 on this building. For this class of building in the 2010 building code, there was no requirement for HRV efficiency. And so this is low-hanging fruit. If I go in here and I just put in a machine with 70% recovery efficiency, and I go back to my Sankey, I can see my EUI at the top here just updated to 297. I can then hit refresh, and that unrecovered ventilation has gone down a significant portion. That's most of my building load. and the number has gone down to 297. So, and the carbon emissions reduce also because the total energy load goes down when you're not having to provide as much heat. So the new section, the one after Sankey, is this the optimization graph. So if I restore a baseline, that will just set us back to where we were, 511 of the targeted model, 508 for the actual building. All of these controls allow me to adjust different components of the building, right? So I can test the red line on the top here. That is the building that I would have to design to meet the building code. The blue line is our building that we're designing. And I've got a few buttons that make it really easy to optimize these inputs without changing the architecture. So what I mean by that is we're not changing window R values or sizes. We're not changing wall R values or roof or anything. We're not changing the envelope at all. We're just tweaking systems and some other approaches like thermal bridging and air tightness. So if we only optimize those things that are really low cost, I will see an improvement in this building. So if we start with restore baseline and then we go decarbonize, what that's going to do is it's going to change the water systems. See, it's gas right now, is a gas heated system. And I go to mechanical here and it's a gas heated building. When I'm in this optimized section, if I say, well, my goal here is to decarbonize, this will change out those systems to make them switch over to a heat pump based system. So now if I look at my mechanical, I've got a heat pump here. And if I look at my water, I've got a heat pump here with a reasonable efficiency level set. So right there, I've got my EUI down to 248.9, and I've got some capital cost allowances for these improvements. So this is the point that you start having a conversation with your mechanical engineer. Say, well, if a gas-fired system is, $500,000 and the heat pump system is $700,000, you could put in a capital budget allowance of $700,000 or 200, because that's the difference. $200,000 for I put in 20 or 2. There we go. The payback is 0.2 years, right? So even if I have a $200,000 capital cost premium on this building, my simple payback target is 0.2 years. So it seems like a no-brainer. The numbers might be different, but that's what it's doing is it's showing you the delta between the reference building with a gas-fired system and your new building with a heat pump system and the capital cost allowance, and then what the payback for that, just that, sorry, I'm looking at the mechanical recovery line. But if I were to do the heating system, I can put in the same kind of thing. I can say it's a $300,000 capital cost premium, 0.3-year payback just for that system alone. So this is where you can really start to go, well, now that we've run a few buildings, we've built up our portfolio, we had confidence in the uses of the building, we can start trying out these different functions and test out what these buttons do. So if I hit optimize, let's turn on the help, because I want to see what these buttons are doing. Optimize shows me apply balanced cost performance optimization with moderate efficiency improvement, blah, blah, blah. And it shows me the things it's going to do before I press that button. So if I hit optimize now, I can get my EUI lower. And if I hit super optimize, this is an expensive version. So I would say decarbonize and optimize are capital cost. They can be capital cost neutral. Super optimize is going to put you into a premium cost, but it's going to still give you good payback. And then passive house is kind of the top of the chain where that's applying an extreme degree of air tightness, thermal bridge mitigation, and a whole bunch of stuff across the model. So I've got 2 minutes left to this is still in the overview section, but if anyone wants to know kind of how the system is working and what it's doing and how it's calculating all these things, there's this thing called dependency graph. So this is more for the academics or the building energy nerds that want to see what the model is actually doing. And this is called it's a D3 is the system it's using. It's a JavaScript viewer. But if I click on any of these things, I can see the relationship between any node in the building and every other node. So if I just make this full screen, I can sort these things by groups and I can go look at, well, what are the totals? And it just isolates the totals. And then I can kind of zoom in on any one of these and see how it's related to everything else. So the way the application is calculating is if it senses a change in any of these things that are downstream, then it updates the whole calculation, but it's only running it for those sets of things. If I look at the water and domestic hot water use, that's this group over here. Oops, let's go back to that. Change to something else, water and DH. This is this blue group here. That's just our domestic hot water. And then if I want to look at the envelope stuff, that's section 11, there's a lot more of these relationships, right? So the bigger the node, this is a total. So it's showing you the total heat loss from all the things that are feeding into it. And then this list on the left shows you all the things that are feeding into it. The window area on the west, the window area on the east. So any of these, I can kind of see what the values are in the model. So that's the dependency graph. That's how the system is working. But for most people, you just want to roll that up and not be looking at that all the time. So you probably wouldn't want to have that printed for your reports. So you can just roll that up. And then when you go print, you'll get all your graphics, but you'll just skip that section, right? So I think now it's time to shift into the Q&A. That gave you a bit of a sense of what the tool is about. Obviously, there's a lot of depth to it. You can really get into, there's a whole bunch of features that we've added as well. Like this one, for example, is moisture risk. So we can see that you get a little water drop. This is section 11 we're in, which is all your envelope stuff. If your window U values are too low, you can actually have a risk of moisture. And if you have a risk of moisture, you can have a risk of mold. So if you put in like 1.5, what kind of value would you need to get rid of that? 1.2, right? So that's like a really fancy double glaze, but it's probably pushing you into triple glaze. Then your moisture risk goes from a water drop to a cactus. And you can see that's going to give you a safe estimate of what you should be targeting for just the human health and longevity, durability, mold mitigation, all that kind of stuff in the U values there. So there's a lot of features all through here. I can't get into them all in one short session, but I think now I'll stop sharing my screen and we'll switch over to QA mode.
Yes, thank you so much, Andy. Just a quick note, Andy is going to be fielding the questions himself. So a reminder to please type your questions into the Q&A box for him there. Okay.
Will the recording be available? Yes, it will, right? This is going to go to YouTube, this one. And I'm sorry, it was a bit of a ramble, but there's a lot to cover in a short period of time. So the main thing is I want to make sure that you've got the link for the resources page. You kind of read through that, understand the disclaimer, some of the points about using the tool, and the performance gap that we've really tried to close by using energy bills and real buildings and working it backwards from that rather than going forward and estimating. So yes, slides are available. Open questions. Here we go. Okay, got it. Presenter's face is blocking part of the content of the slides. Oh, I'm very sorry about that. Too late. I should have hidden that. Only got one poll on the screen. Okay, hold on. I won't read them all. So in future, Shalika, bad idea to have the presenter's head appear over the slides because people can't see the values. I'm sorry. If you open the app in parallel, I don't know if you have big screens, your architects, you might, then you could kind of run it side to side. Can one make an item within the contract for services they provide information such as utility bills? Yes, you can put in whatever terms you want. Pro-indemnity, OAA, this is really between you and the client. So as a negotiation, I think it's totally reasonable. It ultimately reflects in a higher quality building. And you can find things like we've gone back on buildings where we've asked for this. We put it in our contracts. We remind the client, they're like, oh yeah, no problem. We'll go do that. Oh, by the way, here, just log into my account and get the data because I don't want to bother with this stuff. But we can go in there and we can find stuff and go, oh, it's using a lot more cooling energy than we thought. Why is that happening? And you can start to investigate and sleuth out and troubleshoot. And anytime we've done that and gone back and spoken to a client after the fact, they've been like, thank you. I'm really glad you're interested in doing this. And by the way, we've got this another project over in Barrie that we want you to look at because we appreciate so instead of thinking that it's burdensome to put this language into a contract and actually go and do that, and the client's going to be bothered by that kind of thing, I've never heard it. They're always responsive and saying, yeah, I'm really interested and glad that you're coming back and looking for this stuff. Then we can run the analysis, and they're usually interested in knowing how their building is doing, especially if they're going for a high performance target building. So absolutely, I think that's a good one to add into your contracts. And we gave the sample language to do that. I don't know if that's nothing else. Don't worry about it. How do you save your work? So let me just share my screen briefly and I'll show you, just to remind you, when you're in the app and you've done a bunch of changes and I did this optimization thing and everything else, when I go in here and I go export user data, that's the way. You have to export the file to save your work. This is a web app, and as you notice, there's no requirement for a login and a password, and we're not saving data. There's 100% privacy here with the use of this app. So we're not big tech. We don't care about collecting all your information, and frankly, we don't want to be responsible for it either. So when you load this application, it is running on your desktop machine. It is not running in a cloud. It's on your machine. So the only way to save it is to save a file locally and then to re-import that. So just as you exported the CSV, you can re-import it, and that's how you get your work there. It does save it between browser sessions. So I've got 3 different buildings open on 3 different browser sessions. So there's something called local storage. It's built into the browser. As long as you leave your browser open, it will keep the values there. But as soon as you quit the browser, that information goes away. So I hope that addresses how do you save your work. What percentage of your work is for the public sector? Do you find that the average developer is less likely to adopt? When you show owners that there is an argument to be made to save them capital costs, and if they own the building, net operating income. They can increase their net operating income by having a more efficient building. When you start dropping terms like NOI in a conversation with a building owner, they're going to say, tell me more. So here's another example. We do a lot of work where we're using Objective to model for CMHC MLI Select financing, like multi-unit residential buildings. And to get into the tier that gives you the best rates or the best finance, you need to demonstrate how you are saving carbon. And in a lot of cases, I'll give you an example with the tool. Are we still sharing the app? I think so, yes. Okay. Good. So if you look at water, for example, this is a key one for CMHC. I've got all these different methods for water use. There's the PHPP method, there's NBC method, there's OBC, and luxury. So if I'm doing a project where CMHC is providing the funding, I can use the OBC method or the NBC. So these take values from the code for a multi-unit residential building, and they say 220 liters per person of water is estimated for this building, and 88 of those liters are hot water. And I can see here I've got a really efficient heat pump because I hit optimize, and I've got drain water heat recovery. But most MURBs don't have, because the building code doesn't make you do it, don't have heat water recovery as part of the system. So this is something where Grant Walken, one of our technical advisor engineers in Winnipeg, has gone out and field measured multi-unit buildings and tested the efficiency claims or the nameplate efficiency on these drain water heat recovery systems. And guess what? They're a match in the field. So low-hanging fruit here to bump you into a higher tier if you're on a multi-unit residential building is to crank it up to 50, and then you'll see that go up there. So in terms of, well, the owner doesn't want to pay for that drain water heat recovery system. When you can show them that the system cost $5, $10, $15,000 to put in, but its return on investment is within 1 year, then they perk up. They're like, really? It's not that expensive? No, it's not that expensive. So let's consider it going forward. And those are the kind of conversations that happen in terms of average developers and adopting these technologies. And I'll tell you, they are not going to do it out of the goodness of their heart or because Greta Thunberg told them to, but they will do it if it's going to save them money. And so if the capital cost is reduced or pushes them into a better finance tier or their net operating income increases, those are all the things that will prick up their ears, and you'll start seeing more and more interest when we can present this data early. So one of the slides in the deck that I didn't get to show you, but I'll show you now, is when does energy modeling happen, right? So when we teach students in universities, typically energy modeling is happening not when there's minor cost and major influence. You kind of want it to happen then. But when it happens normally, when architects aren't involved, is you get all the way to coordination, and the dot goes in the middle here. You hand off a building that's more or less fully baked, goes to the engineers to basically polish the turd and try and make this thing perform with system tweaks and optimizations, whatever, but they can't do much with the building. So by getting us in front of the energy modeling train, to be able to flag it down before the changes get out of hand or the costs get expensive, that's the best time to do energy modeling. So another example is Objective can be used in an RFP response. So let's say you know nothing about the building except you have targeted area. So you can notice here, I didn't have to load in a BIM file. I don't need a building model. All I'm really putting in are R values, an area, conditioned area of the whole building, and a volume. That's really all I need to get a preliminary energy model set up. So the time to we've done RFP responses where we set a target in the RFP and say, well, if we are awarded this job, this is what we're going to target, and this is what the building code would have you at, and we've got a strategy for the size of windows, we've got a strategy for the R values we're going to target, we've got a strategy for the mechanical system, and obviously you work with your team, your mechanical engineers to figure that out. So those are all uses where early stage modeling is the best way or the best time to do this. Then you can refine your design by the time the engineer finally does their own energy or load modeling. Then they've got a really good idea of what this building is actually going to do. And everyone's on the same page at the same time. If you have a cathedral ceiling, the R value by OBC is less. Where does that show up? You just have to pick an average. It's not meant to be super precise. So the Oh, I see what you're saying. Yeah, you would just change that. So if you can see on my screen and we target into the reference model and we go to the roof here, I can actually change that to whatever the table says because we can't account for every column in every table. But let's say it gives me a lesser value or a greater value. I can type in 6 here for the reference model and that updates everywhere. Or for the building class that I'm choosing, we've decided we're only going to do 3.5. So you have the flexibility to change or override those values manually. And when you save your work, all those values will save out. So that's a good question. So you can override any of the reference model requirements. And it's our responsibility to check against those tables. So in the resources webpage I gave you for OpenBuilding, it has the OAA practice tips for Part 9 buildings, for Part 3 buildings. It's got the SB10 and the SB12 energy efficiency design forum. So all of that data is in there, and the SB12 links and everything are also in there. So just make sure the values match the tables. This is meant to give you a leg up, but it can't cover every possible scenario because storefront aluminum windows are going to be different than thermally broken fiberglass windows. There's lots of variability in those standards, so just make sure you've got the right numbers. Does this all have a manual? Well, we've tried to make the help, the context sensitive help, be the manual. But if you look at our website over here, right, you've got the resources. When you scroll down through here, when you get near the bottom, we've got the history of the tool, and then we get into the references, we've got the videos, then we've got all of these other tools you can use to get more information for inputting your model. We've got our case studies, and then we've got guidance blogs. So if you want to know, for example, how to do the conditioned area and takeoff, you can mouse over that, you can click on that one, and it shows you how to do the conditioned area. And if I want to go back to my index, I can click on that and it should bring me back. Whoops, didn't. Anyways, the blogs, the articles, they're all in here. So if I click on those articles, I can see there's a whole blog on net usable gains. There's a whole blog on domestic and service hot water use, where we've done our own research and we've parsed out the values from all the different standards and tables. So if you need to know more information about how things are calculated or what to do or the numbers to put in, the OpenBuilding website is the resource for that. And there isn't like an official PDF book where we've assembled it all into one thing. So that's the question to the answer, does this have a manual? The context help is one, the blogs are another, and then we've got all those other resources that are another thing. If a designer only has some of the information for which there are inputs, is there any value to be gained from using this calculator? Yeah, absolutely. You put in your best guess. So let's say I know nothing about the building. I don't have an R value set. I'm just going to go a reset, clear everything out. Hit OK. So this refreshes everything back to 0. And I say, what I'm going to do is let's say it's a SB12 building with a heat pump. It's a C4 column. And I just go set values. So what that has done is it's set up the reference model and the target model with the same utility, with the same envelope, basically, values. So now when I scroll down to section 11, I can see I went from my R9 or whatever I had to my roof. Now I'm just matching the building code. Oops, that's not working. That's a bug. It should show 100% for all these things. So we'll make sure that's working. We just made some changes to the calculation engine, so we'll make sure that's corrected. But what it does is it sets up your model so the target and the actual should match. Let's copy this over target model actual. Okay, I'll talk to our CTO. We'll get that fixed today. But the long and short of it is you can put in the building code minimum building and then just kind of optimize from there. So you're going to have to know something about the building, right? It's got a wall, it's got a roof, it's got a window. What does the building code say about those values? And then you're going to know some program area. So even if you have limited information about the whole thing, it's worth kind of taking a stab at this to establish a baseline. And then you basically just add more information as you progress through design to correct values, to refine the location or whatever else you need. So it's always good to set up a model at the beginning, just when you're looking at the program, even in the pre-contract stage, to kind of figure out what the shape of this thing is going to be. Does the entire calculator need to be filled out in order for the modeling to make sense? No, it doesn't need to be fully complete. It's still going to get you in the ballpark. You really just need to make sure the things like the volume, the building volume, which is in section 12, that if it's 5,000 cubic meters, that has a big influence on the ventilation systems, the U values and the R values for the envelope, and then the conditioned area. Those are really the big things that influence the whole system. And then you just keep adding more inputs as you go through the model, and that will refine and get it closer and closer as you add more information. For a building that has several different types of exterior wall, floor, and roof assemblies, what is the best way to account for this when using the calculator? You just have to do a weighted average. So this is a question that's come up a bunch before. We're working on a solution where each line of these part 11 sections, these will kind of become agnostic. So the idea is in a future version of the tool, I can basically click a plus minus and get roof 1, roof 2, roof 3, roof 4, and put those in and then just assign the areas. So that's a pending feature. It's on a roadmap, but right now you have to kind of take an average. So you just total the roofs, put in the average roof value, and use that for now. But eventually, you will see these allow you to create and subtract additional components that have different R values. So you might have like a renovation, or there's 5 different wall R values facing north. Then you can put those all in. So I hope that answers that. What are the security measures for the new calculator? How is the data people are inputting into the system protected? So I spoke to that briefly. This is using JavaScript. So when you load the app in the browser, it is effectively downloading the app into your local machine and storing it in memory there. You could test it by, I could just actually switch off the internet here completely. I'm not going to do that because I'll get cut off. And then keep using the tool, and you'll see everything's still going to function exactly the same way. So there's zero data transmission, nothing is stored in the cloud. It's all happening on your local desktop. So that's the approach to security, because we don't want to babysit data. And one of the problems that the OAA had when it sponsored the Energy Compass tool is the data security requirements required so much legal footwork that it became all about that. So the easiest way to sidestep privacy concerns is don't store data. So we don't. The data it's up to you. If you want to share that with us in a case study, you can send that to us and allow us to use that in a case study. But otherwise, your data is always protected, because basically this system is air gapped. Are there any workshops available on an ongoing basis? That has to do with our 2026 funding. So if you like the idea of this tool and you want workshops to be made available, write your counselor or write a letter to the OAA or OAA council in general and say, we support OAA funding workshops. We'd like to see more of these. And then we'll have more of a budget to do that kind of stuff for this year and next year. Seems a lot of data input is required, such as U values of assemblies. Where is the best place to find this data? Well, we have to do this for the building permit submissions anyways. Somebody's got to do it in SB 10 or SB 12 forms. So the data, basically, the windows come from your window supplier, and then the assembly values for things like walls and roofs and all that kind of stuff. One, I'm not advocating as one the only way to do things, but there's a tool called Ubacus, and it's really good. We use it for a lot of stuff. It's German, So if I open this in a new tab, what does it look like? Ubacus. Um, it's in the resources of the web page I shared from OpenBuilding. It's one of the tools that are listed. Ubacus.de is the website. And what it does is it lets you build an assembly. So if I look at the input section, I can say, well, here's this, what we're doing for walls. I've got a drywall layer. I've got my stud framing cavity. I've got my plywood. I've got 3 layers of stacks. So this is what's called a remote wall detail. I've got a big 2x4. It's like a double wall system or strapping. And that's my assembly. What is the R value? Well, it's R 32.14 in imperial units. But I can click this little wrench and I can say it's in English and German too, but I've got different ways of calculating this. So now, oh, I got logged out. So there's a free version of the tool and you can kind of test it out. For 80 euros a year, it's a really good value because it lets you do all this different kind of stuff. So the best way to figure out what the actual values are going to be is to actually use a tool. So you can see it's in English now. I can go RSI, R value, or U value. So if I wanted the U value of this particular assembly, I can get it in terms of U value, 0.177. Or if I want it in R imperial for my contractor, because he doesn't know what metric stuff is, I've got R equals 32.14. And if I want to get it for RSI, I can go, okay, and then you have this. So this what this does is it calculates the effective RSI, which is what your plans examiners are going to want to see. It's not just a nominal, it's just not just the name of the amount of insulation like R22 BAT. It's actually calculating the actual effective RSI value. And with Ubacus, you can export these really pretty reports. So we've got our firm name on here, and then we've got all our report information, and it does all kinds of stuff like embodied carbon analysis. It gives you a 3D diagram. It shows you what the temperature profile of the assembly is. It gives you a moisture risk warning. So you'll get a little water drop up here if it says, well, I think, this is a bad place to put the air vapor barrier. Maybe you should reconsider. It gives you these kind of warnings. But also importantly for thermal resilience, you get something called phase shift. Down here on the lower right, 6.7 hours. The higher this number, the more resilient your building is. So if you have a heat wave and a power outage, the higher this number means it's going to take that much longer for that heat wave hot energy to work its way into your building. Or same thing, you lose power in the winter. How long will the thermal equilibrium take to pass through the assembly? So phase shift is a really important emerging metric that's worth figuring out how to do. So Ubacus is one tool that will give you that. And once you've got this RSI 5.66, then it can go back into Objective and enter that 5.66 here. So that's where those values can come from. The Wood Council also has a really good tool, but it's a little more limited in terms of the products that you can select. Ubacus gives you brand name U values for or RSI values for all kinds of types of insulation. So rock wool, rock sole, 110, comfort board, all that kind of stuff is available in that tool. Can you provide some information on how to use Section 8 indoor air quality? Yeah, so Section 8 is a bit of a unique one. The reason I closed it is because it's really only there to report what you find in the building. It is not a predictive or a target system at all. But if you have a radon problem, if so, in all of our buildings, we recommend owners install aware systems or air things or something like that. Then in the course of our data collection, we can go back after a year and say, do you mind giving us the report from your dashboard? Because that will export that information. You get a number like 500 for radon, then you can see it is failing the Health Canada guidelines, which is an upper limit of 150. So this doesn't affect your model at all because we're really just dealing with thermal energy and carbon. But if you've got problems with CO2, or the CO2 is like 3,000, which would be a very airtight building, you'll see you get problems if you start putting that in. So this is really just coming from Health Canada guidelines. They've got an upper limit guideline for 1,000 for CO2 and 150 for radon. And here at the OAA building, there's all these air things sensors throughout the building that are logging this stuff at all times. So right after this webinar, we're going to go in and kind of figure out what the building's been doing for the last 3 years, figure out a report, and then we can kind of update this sort of stuff. So it's really just a report tracking and guidance section of the tool. It's not feeding into the energy models at all. Import, export. So we've got 6 minutes left. Great work starting from scratch. Do you have an approximate sense of time needed for a novice to input a complete building? We're always going to recommend taking the 4 hour training. And we do that through universities. We do that in firms. So if you go to the OpenBuilding website, there's a shop section. And don't forget, we're a nonprofit. So we're not making money doing this. We're just basically recovering our costs. But if you load up the shop, it'll show you the workshops in the it's $2,000 for a workshop. But if we get OAA funds, then we'll be able to do more of these and have public participation. So our launch event is in here for tonight. There's still some tickets available if you want to come for that. There's going to be presentations from MGMA, Cool Earth, McCallum Sather Architects, Evelyn Bouchard, Dr. Ted Keswick, he's the director of building science at U of T. They're all going to be doing short presentations and a software reveal of what you just saw today, Objective 4, as well as something from Graphisoft called Project Aurora, which we are also hopefully going to be working on. So we've got these different workshops listed in here. And the big one you really want to get is this one. It's a 4 hour OpenBuilding roadshow. That will get you up to speed with how to use the tool on real buildings. And that will also let us take buildings that you're working on and kind of input them. So we just did a workshop like that for ABC in Montreal, their Atelier Big City. Ran them through a bunch of the buildings that they're working on and kind of help them figure out how to use the tool. And obviously, we encourage people to submit to the case studies once they've gone through these workshops. So that's how that works. What is the gray column on the right of the key values? So let's get back into the tool and look at what we're talking about there. These ones. So the gray values here, if I'm not reporting embodied carbon, I will see not applicable there. So what that means is I'm going self-reported or not reported. But if I'm using a standard, like if I'm trying to comply with Toronto Green Standards 3 or 2, I would put in those values and then I will see, based on the values that I've input in the tool, I'm going to comply with the Toronto Green Standard. I get within 80%, 86%. If I'm over that value, so the cap limit is 400 for this particular standard, and that's in section 5. So let's say my building, I did my embodied carbon analysis and I'm 560. I can see I have failed to meet this tier 2 of Toronto Green Standards. That's what those gray values are telling you. And then the 35%, they're basically just the carbon emissions from the building based on a kind of, if we were to comply with 2030, like there's nothing that's going to make us reduce carbon emissions in Ontario, unfortunately. But if there were, this is what it would say, is you are much better than. So if you're crossing the 100% threshold, it means you've exceeded the value set by whatever standard. In this case, it would be the tiered codes for the National Building Code of Canada, the model national codes. And then this one is just the energy use. So for most of the buildings, so we're not trying to show you really bad buildings by loading up the sample projects here with good buildings. What we're trying to encourage is good practice. So if I load up this mid-rise that's in London, Ontario, I populate the data with that, I'll see this is using half the energy of the building code minimum building, right? So if our baseline is 100%, right, that's this, and this building is coming in at 52%, 49% is basically our net reduction, or it's our 50% is our net reduction based on that. Anyways, that's what those values are meaning. They're percentage improvements over a reference standard. Is there a way to calculate and input a value for saved embodied carbon when you're renovating an existing building compared to replacing new? Yeah, you just type in the embodied carbon of the new stuff against a reference standard of what the noise would be from a new building. So it would just be a really low input in that section 5. So you might just be inputting like 80 or 70 or something like that, right? So that's how that would work. We only have 2 minutes. Let's see how many more questions I can get through. Not sure if it answered, but what if the building faces northeast? Aha. So we had this exact situation in Montreal. So if you go to section 11, or sorry, section 10, because that's where it matters, orientation. The orientation of an opaque wall doesn't matter as much. So that's kind of a trivial thing. We throw that out. But if we've got northeast grid, like Montreal is on a 45 grid, we can put in northeast, southeast, southwest, all these different orientation values. And what that does is it sets up a different gain factor based on the orientation. And I didn't actually know this until we started designing this tool, that southeast is actually your strongest gain because you've got a low sun angle and typically cooler air, which allows more thermal transmission through the window. So better than south. Who knew? So that's what those do. That sets up this is coming from hourly dynamic energy models where we took a stop sign shaped or an octagon shaped building with a meter square building in every rotation or every orientation. We ran it through a bunch of different modeling scenarios for a bunch of different U values and found these numbers. So those are gains functions per square meter of window for different climates and different orientations. Legal question. I'm not a lawyer. I can't answer this one. If modeling targets are not achieved in the final product, what is the extension of liability of the architect? We are not, it's not predictive. It's in the language we use with our clients. It's in the disclaimers and the end user license agreement for the tool. You can't predict performance. It's like predicting the stock market. You can aim for a target and you have to tell your client, this is what we're hoping to get, but you can never assure, warrant, guarantee, or use any of those terms that suggest you're actually going to get there. What we're finding with use of the tool is we're getting really close. Like we're getting a lot closer than a lot of other methods and frameworks, but you still can't tell a client you're gonna meet these targets. So that's fraught language. Be really careful around that. So coupon does not work for the event. If the coupon doesn't work for the event, that means that we've run out of capacity. So I'll take a look at that after the session. You can try it again in like 15 minutes and I'll see if there's actually any more space. Otherwise, it is a roadshow one group price for a whole firm? Yes, it is. So if your whole firm wanted to do, it's it's a one shot deal. Basically, it's just cost recovery for mileage and accommodation and whatever to get out and to purchase our workshop materials. So yeah, the price doesn't go up or down with people. Awesome. I think that's all the questions. Our time is up. I'll stop sharing my screen, and next time I won't share my head in the queue.
Now we know, yeah. Perfect timing. Thank you so much, Andy, for this really excellent presentation and for the discussion today. And thanks so much to everyone who participated in the polls or by submitting your questions. We really appreciate it. I just have a few closing announcements as we conclude this webinar. So again, for those who are seeking continuing education learning hours, the OAA will record your participation in this webinar on your OAA transcript, so there is no need for individual reporting on your part. We just kindly ask for your patience at this busy time of year as we process and confirm the accreditation of your hours within the next few weeks. As well, all attendees will soon receive a PDF copy of the presentation along with a link to a survey to submit your feedback for our webinar presenter. We highly value your feedback and our presenters do as well. So if you do get a moment, we appreciate if you complete that survey. Finally, our next webinar will take place next Wednesday, February 18th, with the title Advancing Civic Infrastructure, Mississauga Fire Station 123. So this is another climate action webinar. And so if you are seeking structured climate action hours, please be sure to check that one out. And with that, I want to thank Andy once again and thank all of our attendees for participating in this excellent webinar, and have a pleasant remainder of your day.
One quick note, Shalika, while
Oh,
I've still got people, if the
yeah.
coupon doesn't work, don't worry about the coupon code because if you're an OAA member, you can just put in $30, whatever, and don't pay it. Just
Oh,
say interact transfer or something like that, and it'll say processing in the system, you won't be charged at the door or anything like that. So just let me know that you were on this webinar this morning and we'll let you in. So you can come by for a drink. We can accommodate another 20 people. That's the reason I'd ask you to just fill out the form anyways, but you don't have to put in your credit card information or anything like that. Awesome. Thanks. Come
perfect.
by. We'll hopefully see you over a beer or a glass of wine. Take care.
Thanks so much, Andy. Bye,
Bye.
everyone.